In this segment, we'll finish our discussion of Java exceptions, looking at exception handling as an example of object-oriented design. Exception classes make heavy use of inheritance, but it's not so that subclasses can add extra methods or members. Exception classes are all pretty simple. They all store a string message, can provide a stack trace of the exception point, and so forth. Instead, exception classes are organized into an inheritance tree to let us group exceptions by their superclasses. The diagram here shows a rough map of it. You don't need to understand it all just yet, of course. We'll be discussing it all during the lecture. A catch block may catch all exceptions in a branch of this inheritance tree by catching their common superclass, like catching all that are below exception or all that are below runtime exception. As with interface inheritance, the exception inheritance is all about ISA relationships. The exception class's inheritance tree is quite deep, as you can see here. An exception class may have over half a dozen superclasses between it and object, and of course object is implicitly a superclass of throwable. Question 1. Of the exception classes that scanner.nextInt might throw, one is a subclass of another. Which one is that? And how many superclasses does it have, including object? Obviously, go look at the Java docs for this. So, returning from the pause there, we have our scanner class. We go down and look at nextInt. And we actually discussed these in the earlier lecture as well, but we didn't look in detail at them. Input mismatch exception is derived from no such element exception, which is another of the exceptions that can be produced. So it's input mismatch exception that we're after here, and it has 1, 2, 3, 4, 5 superclasses. And that input mismatch exception is a subclass of no such element exception makes sense when you think about it. No such element exception means that nextInt couldn't find an integer. There's no such element. And input mismatch exception is one reason you might have no integer. The input may have been of the wrong format. So it's a specialized or more specific version of no such element exception, and it makes sense as a subclass. And question 2. Let's take a look at get and init config. Right up here, and then looking here at the catch, you can see it only has a catch block for no such element exception. But the calls of nextInt and other scanner calls, in fact, might produce input mismatch exceptions too. We'll get init config throw any input mismatch exception back to its caller. Returning from a pause. No, it won't. The catch block accepts anything that is a no such element exception. So it catches both no such element exception and input mismatch exception, its subclass. Now that's a typical example of using an ISA relationship to group exception handling. Per usual, if you have a reference to a superclass, like no such element exception, you can assign or pass to it any subclass, like input mismatch exception. Now alternatively, we could have caught input mismatch exception separately by putting a catch block specifically for it ahead of the one for no such element exception, since the first applicable catch block is the one that gets used. So had we done this, then we would have had individual catches for the two subclass exception and its superclass exception after that. And while we're at it, note that an exception, or catch block I should say, may throw another exception to be handled by catch blocks further up in the call chain. And this is typically done to concentrate a variety of exceptions, like our two here perhaps, into a single exception for handling by a caller. The no such element exception catch block, in a sense, converts the no such element exception into a CWS exception, and it ensures that all exceptions coming from get and init config are then CWS exceptions. Question 3. The two catch blocks at the bottom of main, down here, both do the same thing. They handle the error in the same way. Now, how might we merge them into a single catch block? You'll want to look at the Java docs for IO exception, which is in the java.io package, and the code for CWS exception Java, which is in the code world's source code, actually, right here. So, looking at those two, what we can see is that we could make a single catch block for Java lang exception, which is a common superclass of IO exception, right there, and CWS exception. And using throwable, by the way, would also have worked, though not object, since, as we said earlier, any thrown object must be of a class derived from throwable, or throwable itself. Now, exception is a superclass of almost every exception class used in practice. Indeed, lazy developers sometimes just stick the following after a try block as a catch-all, so to speak, and put it here in the notes as well as in the transcript. Just catch exception, and that catches anything derived from exception, which, as you can see, is an awful lot of stuff over here. But well-designed production code is usually more thorough and reports distinct messages for different kinds of exceptions, grouping only very similar ones together. The exception class hierarchy in effect lets you dial up precision by catching classes further up or further down the inheritance tree as you choose. Now, it's often useful to add an exception class or two of your own to distinguish exceptions specific to your code from those generated by the libraries, or to concentrate a variety of exceptions into a standard exception class for the application. CWS exception in code worlds is an example. As the CWS exception.java class here illustrates, added exception classes almost always derive straight from exception. And they add a string accepting constructor to call the corresponding constructor in exception, so that the new exception class can carry a descriptive message string. In many cases, that's all that's needed. You can add as many member data and methods to an exception class as you like, but this is rarely useful. The point of having your own exception class is to distinguish it by type in catch blocks, not to add a lot of extra information. And CWS exception is typical. Question 4. Look at the various exceptions in java.lang. Most derive from a common superclass that is itself a subclass of exception. And what superclass is that? Returning from a pause, what you should find is that a lot of them derive from something called runtime exception. And all of the runtime exception subclasses here in the tree represent errors that might occur as the result of code bugs, like, for instance, a null pointer exception or an array index out of bounds exception. You can catch such bugs as exceptions by enclosing the possibly buggy code in a try block, and by catching either specific runtime errors or by catching the superclass runtime exception to cover them all. It can sometimes be useful to do this, but there's not usually a recovery strategy for a bug. Retrying the code is just going to result in the same bug. So more often you just leave such exceptions uncaught, and you let them throw all the way back to main, where they cause program termination with a stack trace showing the point of error. But this does raise a question. Does the catch or announce rule require us to announce that a method throws runtime exception if the method doesn't catch runtime exception? This would be a bit silly, as potentially any code might have a bug. So the catch or announce rule exempts runtime exception and its subclasses from the requirement to announce. And this is another example of using the exception class hierarchy to categorize and specially handle groups of exceptions. And then one final point. We've thus far discussed subclasses of exception. But you can throw and catch any throwable, which is a superclass of exception. Throwable has only two subclasses. One is exception, which we've extensively discussed. The other is error, which has subclasses for really bad problems that you probably won't try to catch, like a corrupted bytecode file or major configuration error in the JVM. And as for runtime exception, methods don't have to announce that they might throw error subclasses. So, summarizing the exception class hierarchy with reference to the diagram here in the notes. Point 1. Throwable is the superclass of all things try-catchable. Throwable has two subclasses representing major categories. One is error, for things so grave that they aren't your code's fault generally, like blow-ups in the JVM due to configuration or other problems. The second is exception, for things that usually should be caught. Under exception, there is a further subclass, runtime exception, for runtime bugs like null pointer exception that are your code's fault, but are routine bugs that you probably won't catch as exceptions either. There are also many other inheritance branches under exception, like I/O exception, for instance, and its many subclasses. These subtrees group exceptions at finer and finer levels as you descend the inheritance tree, and you can use these hierarchies to design catch blocks that catch specific exceptions or entire categories of exception. And then finally, point 5, neither error nor runtime exception require announcing. Now that's it for exception handling. In the next segment, I'll ask you to read much of the remaining codeworlds.java code and answer questions on it, and we'll discuss another design pattern, which is strategy.